So on this video we're looking on how we'd write the PD lab for this problem statement. So some students might get confused and say that this isn't Ohm's law, but what your teacher is expecting is that you will be able to to transpose this formula from this form into a linear form. So the problem statement is saying that you actually have a electrolyte solution which is made of from an acid, and you're supposed to plan and design a lab that you're able to find the values of K and N. So your hypothesis should be something simple. I'm gonna scroll down and we're gonna look on an example. Before we go there, there's some things that you need to know about. So I'm just gonna make some highlights. So we're gonna look at the electrolyte component. So this is gonna be important for your method. You're given this equation. It's not a linear equation, so we expect you guys to do some logs, and also we're going to manipulate values of current I and voltage. The setup is the same as in any CSEC lab. You have your hypothesis, your aim, your apparatus, your variables, variables manipulated, responding, and control. You need a diagram and a method. You're going to analyze the data, limitation, and source of error, precautions, and your conclusion. I think we're missing, well, could have put in expected results, but this can be placed inside your data analysis. So looking here, get a feel with the electrolysis method, and we're going to move forward. So we're going to look at an example. So this is a lab that someone did. It was lab number 4. The problem statement is said that the voltage is inversely proportional to the current I. You could have guessed that it's proportional. It's just that you need to plan a lab that will actually show the relationship between these two. Now we're going to look at our apparatus. We're going to need some electrodes, beaker, so on and so forth. I'll go to the diagram. The diagram here is going to show, well, since we need to vary our current and voltage, a rheostat is needed. So that's a key component. You need a power supply, switch is good, the ammeter is good, the electrolyte in the container. This person is using a potentiometer. A voltmeter could be used as well. So this is a very good setup of what's going to happen, and you could get the setup based on what is said in the lab. So you could look at that a bit if you're not comfortable with the concept of an electrolyte. So that's important. Some person might be going over this again and thinking that it's Ohm's law. It's not. So let me show you what important aspect you want here. So you could go ahead and set up the lab, like for example an electrolyte lab, electrolysis lab, taking values of current and voltage. But then you're gonna need to plot a graph in order to find the values of K and N. This is taken here, where what you do, you log both sides. Then you would actually set log V is equal to log K minus log N log I. So this conversion here is really important, and it will tell you what data you need to collect. So you'll go up here and know that you have resistance, you need current, you need voltage, you need to get log V and log I. Looking at that now, this is in the form of y is equal mx plus c. Therefore, you put the value of log V on your x-axis. Your c would have been log k, which is the y-intercept. Your n would have been the gradient. So after you have collected this data, you need to plot a graph, and from that you'll be able to tell the values of K and N. So that's the important portion here. Electrolysis, so that's the basis there. Electrolysis will be there. The terminal setup, it's physics, so it's gonna be a simple electrolysis circuit. But this is a portion here that makes it an advanced lab. The logging of V, logging of I, converting this equation from this form into a linear form, knowing that you can, if you calculate the gradient, you'll actually get the value of N, and the log inverse of K would actually have given you that value there. So now that is the most important thing there, and we expect to see that. That now would have been, since it's in your problem statement, look at your aim. It says that to determine the value of K and N. Notice that the list of apparatus here were actually in that diagram there. Manipulated, control the volume of the acid. That's okay. You manipulate the, I think I disagree with this one here. You manipulate the resistance of the rheostat, and then what will happen is that the voltage and current will actually change. So this should have been right there, and having all of that in place would actually give you the full marks of that lab.